This shouldn't take very long, just to let you know. We're just going to go over the free response, and I'm going to give you the answers to the multiple choice, and then just make sure you study everything that's on this review because it's going to be on the test. Okay. Remember that we're splitting our stuff up, and it's going to be you're going to take your free response tomorrow, and then on Wednesday you're going to take your multiple choice part. We will not Zoom on Wednesday, so the only way you will get credit for being on Wednesday is to turn in your assignment. Everybody understand that? Okay? No excuses. You have to turn it in. If not, it's a zero for the test grade and an absence. All right. So the very first one, 7.1, it asks you to identify the population, the parameter, and the statistic. I'm going to go a step further and also do the sample just in case. Okay, so we started with population. And remember, your population is wherever the sample comes from. So our sample was 500 males with high blood pressure. We know that because they were randomly selected. So your population is all males with high blood pressure. So again, you should just check your answers. If you don't have what I have, make sure that you write it down. If you want to get a separate sheet of paper and make like an extra spot, that's perfectly fine. Okay. So then we have parameter. Parameter would be like, what are you trying to figure out? So it says after weeks, their blood pressure is measured and the average arterial pressure is calculated. So we're looking for the average arterial blood pressure for all males. And again, that's for the population. So yes, you do need to make sure that you put all males. If you didn't put it, it's not a huge deal. Okay, make sure that you put it now and on your test if it asks you to do this. Then the one that it didn't ask you to do is the sample, and I'm going to go ahead and do that. And you know that your sample is 500 males with high blood pressure. And then the last thing is your statistic. And this one didn't give you a specific one like part B did, but remember what you're looking for. We're looking for the sample. Statistic goes with sample. We're looking for the mean or the average arterial, I cannot spell, blood pressure. Okay, so the sample mean arterial pressure.
I have a small question.
Question away.
In, I guess, just statistics in general, I saw that sometimes they use parameter as like the condition. So what would you call that if we're using parameter as like the number for the population?
Okay, so for parameter, what do you mean by the number population? Let me make sure I'm
Okay,
answering
so
correctly.
parameter is like in this case the average blood pressure. But what if parameter you put like was the blood pressure like the condition it has to be to like I guess meet
That's fine. It's fine. The blood pressure is perfectly fine. They're just talking about overall, what are you looking for? In this case, it was average. So this would be the population average arterial blood pressure. If you just put arterial blood pressure for all male, I would take that. Okay. But then down here, just make sure that you mention that it's the sample. Okay. That's the only difference. So you're perfectly fine putting that. All right. Part B says a study is conducted to determine whether or not the dangerous activity of texting while driving is a common practice. 1,500 16 to 24-year-olds are randomly selected and asked whether or not they text while driving. Of the 1,500 drivers, 12% indicate that they text while driving. So remember, your population is who did they sample? So here was our sample. So population is 16 to 24-year-olds. And if you want to put all, that's fine as well. Okay, so all 16 to 24-year-olds. The parameter is what are they measuring? It's the proportion. You could say the percentage of texting while driving. Again, they didn't ask you to find the sample. I just found it for you or wrote it down because we were doing that in our homework. Would be the 1,500 16 to 24-year-olds. And then in this one, they gave a specific statistic of 12%. And you might see it, you guys know that, as 0.12. It doesn't matter which one you give me. Okay. So any questions on population, parameter, sample, or statistic? All right, moving on to the next one. Not everybody in class, but most everybody in class was asking about this one. How do you sketch a population distribution? If we're talking about rockets and astronauts and planets and stars and crescent moons, those are categorical data. So we're going to make a bar graph or a histogram, okay? Bar graph or histogram. We're going to make a bar graph. So this is what it's going to look like. And mine's going to be really rough, and it's okay. We're going to write our percentages. It's the population distribution. So we start with, you can do stars, crescent moons, rockets, astronauts, planes. It doesn't matter what order it goes in because it's categorical, okay? So it does not matter. So on the side, I'm going to put 10, 20, 30, and 40. And I'm going to label this the percent. And then the first one I'm going to start with is stars. So I'm just going to put an S. Stars were 10%. Crescent moons were 10%. Rockets were 20%. And it doesn't have to be anything pretty. I would accept exactly what I'm writing right now. Astronauts were 40%. And planets were 20. That's it. Okay, don't make it more complicated than what it is. Now, if they give you a mean and a standard deviation, which they will in just a few minutes, you're making like the normal curve, and I'll explain to you exactly how to do that as well. Okay. So it says, suppose you were to collect a random sample of 2,000 marshmallow shapes, sketch the distribution of sample data you would expect to see. It says, how many rockets would you expect to see? So what you're doing is doing 200. So we need to find 2,000. We need to find 10% of that, 20% of that, and 40% of that. So I did 2,000 times 10% was 200. I did 2,000 times 20% was 400. And 2,000 times 40% was 800. Your graph is going to look exactly the same, except for your y-axis is going to be labeled with numbers instead of percentages, okay? And you want to label them kind of the same way. The only thing that I didn't do, 10% is 200, 20% is 400. We didn't do 30%, but we know that it's 600. If you want to just take them by your desk and a trash can by your desk, you can do that too. I'm just trying to save you some time. You're not bothering me. And then 800. So that way your scale is still 4 numbers on the left or on that scale. Okay, so it looks exactly the same. So your stars would be 200. Your crescent moons would be 200. Our rockets, which it asked for, would be 200. I'm sorry, 400. Sorry, y'all. And then our astronauts are 800. And planets are 400. So it'll look like that. It's okay. I wanted to show so you guys knew. Nope. Nope. Unless it says show your work. Yeah. So you'll be fine. So if you didn't show this part up here, that's fine. I'm just showing you where I got these numbers from. So as long as you have this distribution, it is correct, and you have that rockets are 400, you get the full credit on that. The only way you would need to show this is if they say show all work. All right, so now suppose you collected many samples of the same size. Sketch the sampling distribution of the proportion of rockets you would see in the samples. Okay, so here's the thing. We're collecting many samples. That means it's going to pull it to a normal curve or a more symmetric curve. That's the whole point of us taking samples, which means it's going to center itself at the mean. So we need to find the mean, which is the same thing as the mean of the population. And we're talking about rockets, the proportion of rockets. So what was rockets? What was the proportion of rockets? 20%. Perfect. Sarah, I just got your email, so it went through. I cannot promise it'll be the right thing if you send it through Gmail. I mean, if you send it through your drive. So I'll just have to check it. So just be patient. All right. So then we have to find our standard deviation. Remember the way we find our standard deviation is P1 minus P over N. The only different formula that you will have is if they give you the population standard deviation. So right now they didn't give you the population standard deviation. I will show you those. I think they're in 7.3. So this is the formula you use for standard deviation, which is 0.2 times 0.8 over 2,000, which gives you 0.009. So then to sketch this, your mean is at 0.20. We do 3 standard deviations above and below, so make sure that you remember how to do this. This has been a while, so it's okay if you don't know. That's why we're reviewing it. You do your 0.20 and plus 0.009, gives you your first one, 0.2009. Sorry, 0.209. Add 0.009. This one is 0.218, and I'm putting it up there so that I'm not squishing them down here and you can see them. And you can probably do these in your head and that's fine. Plus 0.009 is 0.227. To find the other one, minus 0.009, so 0.191, 0.182, and 0.173. And you do this a lot within this little review packet, so just be ready for that. So that's your sketch. Notice we pulled out one category to make it quantitative data. Okay, we didn't use all the other data. There's no way that you can do that. Okay. Any questions on that 7.1? All right. (7.2). It's talking about the potato chip factory. It said, suppose that a truckload of potatoes contains 95% that are acceptable for processing. If more than 10% are found to be unacceptable in a random sample, you must reject the shipment. To check, you randomly select and test 250 potatoes. Let P hat be the sample proportion of unacceptable potatoes. P hat is the sample proportion of unacceptable potatoes. How many potatoes are acceptable? What's it say? 95. So if 95 are acceptable, 5% are unacceptable. That's it. Everybody good? All right. So then part B says check the 10% condition and calculate the standard deviation of the sampling distribution of p hat. So remember what we talked about. So when we get to 7.3 and maybe the second part of this one, it doesn't tell you to check it, but you must check that 10% condition before we can find the standard deviation. So the 10% condition is we're making sure that the population is greater than 10% or the sample is 10% of the population. Okay, it cannot be greater than 10%. So 250 times 10 is 2,500. And we know that the population is larger than 2,500 potatoes. Okay. Is everybody good with that? You good? All right, so then we found the 10% rule, so now we can do the standard deviation. I told you that there was only one formula right now for that. So it's your P, which was 0.05, times 1 minus your P over your sample size. Which gives you 0.0137. So the thing about this question is it lists out everything that you should do in one question over 3 or 4 questions, okay? So make sure that you're doing all of these things when it asks you what is the probability that this will happen, okay? Check the normal condition. What is the normal condition? Is that NP and N1 minus P is greater than 10. So NP would be 250 times 0.05. N1 minus P would be 250 times 0.95. We have 12.5, which is greater than 10. And we have 237.5, which is greater than 10. All right, so do you think it would be likely to reject the truckload? So based on the random sample of 250 potatoes. So here's what happens. It says based on this sketch, we haven't sketched anything yet. I just showed you how to sketch. Our mean was at 0.05. We do 3 standard deviations above and below with our standard deviation of 0.0137. I'm going to go above 0.0137, gives us 0.0637. The next one is 0.0774. And the last one is 0.0911. Below, and again, these should go down there, but I don't want to squish them up for you not to be able to read. One below would be 0.0363. 2 below would be 0.0226. And 3 below would be 0.0089. When do we reject the truck or the shipment?
10% is bad.
Yeah, greater than 10%, right? Look at this distribution. 10% falls right here. Think about that percentage. How likely is it that we're going to reject the truckload? How likely is it? Yeah, think about that shade. Remember way back when we did this, if the shade is teeny tiny, then the probability is teeny tiny, okay? So are we gonna reject it? No, because 10% is more than 3 standard deviations above the mean. So 250 is not a good sample size. With 95% acceptability. Okay. All right, so remember, we don't want it to be above that 3. All right, so the next one puts it all together. Okay, the next one puts, instead of splitting it up into A, B, and C, you do all of it together. A phone company is interested in exploring marketing possibilities for a new smartphone for teenagers. They ask an SRS of 1,000 high school students whether they own a smartphone. Suppose that 65% of all high school students own a smartphone. What is the probability that a random sample selected by the company will result in a p-hat value within 3 percentage points of the true population proportion? Show all your work. So the first thing that you need to understand is that they did not say anything about this being normal. If they say normal, you don't have to do all these crazy tests, okay? This one says, it doesn't say at all whether it's normal or not. So we're gonna go through it. The first thing that we need to be able to do normal, we need mean, standard deviation, upper and lower, right? So normal CDF, upper, lower, mean, and standard deviation. So the first thing that we can absolutely do is the mean, because it's gonna be your p-hat, which is what? What is your proportion? Next, I need the standard deviation. What do I have to do before I do the standard deviation? So I'm going to do 10 times the the sample. Do you think there are more than 10,000 students who own a smartphone? Yes. So this is okay. So now we can do our standard deviation. Our formula. The reason I write the formula is because that defines the variables for you and you don't have to write them out like n equals and p equals or whatever, okay? So these will be your p-hat or your proportions. So we're going to do the square root of 0.65 times 0.35 over our n, which is 1,000. That gives us a standard deviation of 0.015. We still don't know if it's normal, so what do we have to do? So right here, we check the normal condition. It's okay. So again, this one is all together. So we do NP and N1 minus P, and they have to be greater than 10. So we're doing 1,000 times 0.65, which is 650, which is greater than 10. Then we're doing 1,000 times 0.35, which is 350, which is greater than 10. So again, 10% rule, make sure that you can do standard deviation. Normal condition, make sure that you can use normal, CDF or PDF, okay? So what are we trying to find? We're trying to go within 3 percentage points of the true population. So what was our mean? So what are our percentage points within 3? Good. Add and subtract 0.03. All right. So we can use normal. And we're going to use CDF because it is inequalities. Our lower is going to be 0.62, our upper 0.68. Our mean was 0.65, and we found our standard deviation was 0.015, which gives us a 95% chance. And that means that there is a 95% chance that a randomly selected high school student owns a smartphone. And again, with showing all your work, when it said show all work, make sure when you get to this point, you define this as lower, upper, mean, and standard deviation if you're going to use your calculator. Okay, again, define everything. All right. I don't have a copy of 7.3. I didn't make enough and didn't realize it. So we're going to look at 7.3 real fast. I have a copy I'm not going to write on. How about that? All right. This one says the time it takes fifth graders to complete a particular mathematics problem are normally distributed, so we don't have to do any of that work. Okay, it already tells us that they're normal, so we can go ahead and use normal CDF. With a mean of 2 and a standard deviation of 0.8 is our standard deviation, so we don't have to do 10% rule or anything like that. Find the probability that a randomly chosen fifth grader will take more than 2.5 minutes to complete it. Okay. So it said it was normal. We can use normal CDF. We're looking for the probability that X is greater than 2.5. So what is your lower? 2.5. What is your upper? Yeah, ridiculously large number. What's your mean they gave you? And your standard deviation. When you put that in your calculator, you should get 0.266. All right, so this is the overall population, okay? This is all fifth graders. So then on the next one, it says, suppose you give the problem to an SRS of 20 students instead, 20 students, so now we're taking a sample. Sketch the sampling distribution of X bar, then use this distribution to determine the probability that the mean time to complete the problem for the SRS of students is greater than 2.5 minutes and show your work. So you don't have to use the probability. You can use your normal CDF, but you need to draw it, okay? Because it says sketch it. So when we do this, the mean of X bar, remember, is the mean of the population. Sorry, which is 2. It gave you the population standard deviation. So this is where our formula differs, okay? If they give you the population standard deviation, you're putting that on top of the square root of your sample, okay? We didn't get a proportion. We didn't get 95%. We didn't get 65%. So our standard deviation is going to be 0.8 over the square root of 20, which is 0.1789. You can do 0.179, that'll be fine. It asks you to find the probability that's greater than 2.5. So the same thing that we just did, but we're using a sample. So I'm going to put the X bar up there. Remember, if the population is normal, then your sample is normal. Okay, that doesn't change. Our lower is still 2.5. Our upper is still a ridiculously large number. Our mean stayed the same, but our standard deviation has changed. And this will give you 0.0026, 0.0026. I've showed you how to sketch it twice now. So your mean was at 2. Your standard deviation was 0.0026. So 2 plus 0.0026. You can add it again. And keep going. And then we wanted it greater than 2.5. I'm not doing the right numbers. Hold on. I think I got to use the other one. Hold on, y'all. Stop. I don't know that I copied this down right. 2.178. Yeah, I did. All right, but these should be of the population. So the 0.266. So 2 plus 0.266, which is 2.266, 2.532. And then your 2.5, it said greater than that, is going to be up this way. Okay. All right, so just know how to use this to graph your, you're not going to do this on your test at all. This is just review. So this is not something that you need to study. It's just bringing it back from like way before. All right, the last problem, I think it's the last one. Yes. The blood cholesterol level of adult men has a mean of 188 milligrams per deciliter and a standard deviation of 41. An SRS of 250 men is selected and the mean blood cholesterol level in the sample is calculated. Sketch the sampling distribution of X bar and calculate the probability. I don't care that you don't sketch it. That's perfectly fine. But we need the probability that X bar is greater than 193. Is it normal? Is it normal, yes or no? Do we know? Did it tell us? No, so we need to make sure we do all that stuff to tell us that it's okay to do. So your mean and standard deviation is up there. We don't have to calculate the standard deviation, so you don't have to do the 10% rule because they've already calculated it for you. And then you just want to check the NP and the NP minus 1 or whatever. But we're going to go ahead and go through. Our mean, they told us, was 188. Our standard deviation. We're doing a sample now of SRS of 250. So we do our population standard deviation that they gave us 41 over our sample. And our sample was 250, the square root of the sample, which gives us 2.593. So again, if they go ahead and give you the mean and the standard deviation of the population, you're just going to go through with it. We want the probability that X bar is greater than 193. So we do normal CDF. What's our lower? Upper. Yeah, mean was 188. Standard deviation was what we calculated to be 2.593. And then when we finish this out, we're going to get 0.0269. If you're graphing it, You're gonna have your mean at 188. You're gonna add this 0.0269 and subtract it, and you'll get it like right here. And you guys look, it's like 2% of the graph is exactly what you're looking for. It should be a tiny little space. All right. For multiple choice, I'm gonna go ahead and give you those answers. If you have questions about multiple choice, just let me know. I'm gonna write them down so you can see them. Number 1 should have been A. Number 2 is C. Number 3 is B. Number 4 is B. Number 5 is A. Number 6 is C. Number 7 is A. Number 8 is B. 9 is A. And 10 is C. Any questions? Those of you that did not upload your review in time, if you want to upload this review, like where you completed it with me, you can get a 50 for it. Got it? All right, Zoomers, stay on. I'm gonna stop sharing, stop recording.